Hello everyone, and welcome. Today, we're going to unravel a common term you'll encounter in thermodynamics and steam tables, HFG. It might look a bit cryptic at first, but it represents a very simple and fundamental concept that is key to understanding how things like power plants and air conditioners work. So, what exactly is HFG? Let's break it down letter by letter to make it easy. In thermodynamics, the letter H stands for enthalpy, which is essentially a measure of the total energy within a system. The subscript F stands for fluid, but it specifically refers to a saturated liquid. A saturated liquid is a liquid that is right at its boiling point for a given pressure. The subscript G stands for gas, specifically a saturated vapor. This is a vapor that is right at its condensation point. So, when you see HF, it means the enthalpy of the saturated liquid, and Hg means the enthalpy of the saturated vapor. This brings us to HFG. The term HFG is simply the difference between the enthalpy of the saturated vapor and the enthalpy of the saturated liquid. The formula is HFG equals Hg minus HF. This value represents the amount of energy required to completely change a unit of a substance from a saturated liquid to a saturated vapor, all while keeping the temperature and pressure constant. You might know this by a more common name, the latent heat of vaporization. Let's use a simple example, boiling water on a stove. Imagine you heat a pot of water until it reaches 100 degrees Celsius, its boiling point at standard atmospheric pressure. At this exact moment, it's a saturated liquid, and its energy content is represented by its enthalpy, HF. If you continue to add heat from the stove, the water's temperature won't increase beyond 100 degrees. Instead, it will start to boil and turn into steam. All the energy you are adding during this boiling process is the HFG. This is the energy needed to break the bonds holding the water molecules together as a liquid and allow them to escape as a gas. Once every last drop of liquid has turned into steam, still at 100 degrees Celsius, you have what is called a saturated vapor, and its total energy content is now represented by its enthalpy, Hg. So, you can see that the final enthalpy, Hg, is just the initial enthalpy, HF, plus the energy you added to make the phase change, HFG. This value is incredibly important for engineers because it tells them exactly how much energy is needed to create steam for a turbine or to vaporize a refrigerant in an AC unit. You can find the values for HF, Hg, and HFG for substances like water in reference books called steam tables. Thank you so much for watching and sticking with me to the end. I hope this explanation made the concept of HFG much clearer for you. If you found this video helpful and want to see more simple explanations of complex topics, please consider liking the video and subscribing to support the channel. It really helps us create more content for you. See you in the next one.